So in section 1 we learned about voltaic cells, and then the very last vocab word was the word battery. Okay? And then section 2 is all about the different types of batteries. Your book focuses on 4 main types. Some of them you need to know a lot more about, some of them you just need to recognize why they're important. So the first one it talks you through is a dry cell. Okay? So a dry cell is, if I were to tell you to go to the store and buy me a pack of batteries, you are going to the store to buy some dry cells. And most of the batteries at the store are all 1.5 volts. Okay? And that is because the zinc casing is always the anode for a typical dry cell. You can use other substances, but the standard we use in America and most places to create a 1.5 volt battery is that we make the zinc casing the anode, and then through the center of the battery is a carbon rod that acts as the cathode. And then inside of the battery is like a paste, so it's not liquid, which is why we call it a dry cell. It's almost like peanut butter. And so that peanut butter has enough liquid in it that the electricity can travel from the anode to the cathode, but you don't shake a battery and hear liquid sloshing around in there. Okay? Within there, and this question always comes up when we start talking about batteries, how come some are rechargeable and some are not? Okay? If it's a primary battery, okay, then it is really, really hard to reverse the voltaic cell that you just did. So that would be a battery that it wouldn't be worth your time to recharge it. So we would say it's not rechargeable. Even though you could recharge it, it's not worth your time because it's too hard to do it. Okay? Your cell phone battery is easily reversed, which is why we can just plug it into the wall and recharge it. Okay? Those types of batteries are easily reversed, and so they are a lot easier to recharge. You just need to know we use these 2 words in chemistry. We don't say chargeable or non-chargeable. We say primary and secondary. So just make sure you draw one of those in your notes so that you have a good idea of, okay, a dry cell is always this, okay, and have a picture that goes with it. Okay? The next one is a lead acid battery, which will come in handy. Most of you guys are in 10th grade. You're getting your driver's license here soon. The lead acid battery is the one we use to start your car. Okay? So I put a little star there. This is a car battery. Again, the book has drawings of it. I'm not a great artist, so I'm going to let you look at the pictures in the book. But basically, you have 2 different kinds of lead in a lead acid battery. Okay? You've got normal lead Pb, and you have lead 4 oxide. Okay? The atomic lead is going to oxidize to become Pb plus 2, and then the lead 4 oxide is going to reduce to come back down to plus 2 and recreate some lead sulfate. Okay? Now you'll notice you need sulfates in both the oxidation and the reduction. Okay? But then that's why you need the acid in there, because we use sulfuric acid in your car battery. It's super strong, okay? And that's why if your car battery is not working, you're not supposed to cut it open and go play with it, okay? There's concentrated sulfuric acid in there, but there are 6 different voltaic cells inside your car battery, and each one is a thin plate. The first plate is lead, the second plate's lead oxide, the third plate is lead, the fourth plate is lead oxide, and it's running 6 of these all at once. And that's because if you run the voltage for this, it generates about 2 volts per cell. And your car motor requires 12 volts to start. So what we do is we have one big battery, it's pretty heavy, that operates 6 of these at once. And so 6 2-volt batteries is the same as one 12-volt battery. And so that's what we use lead acid batteries for. Lithium, the Nobel Prize this past year was given for the person who invented the lithium battery. Lithium batteries are cool because they are very, very light compared to all other batteries, because lithium is the lightest metal that there is. It's element number 3. And because lithium's at the very, very top of the reduction potential chart, it gives you a lot of voltage for a very, very light battery, okay? And then the book walks you through and explains why they're so useful. But basically, if you have any electronic equipment that will keep your time or your date or any information between you powering it on and powering it off, there's probably a little circular lithium battery in there that keeps running even though the power's off, because those lithium batteries can last a long, long, long time. And if you build a secondary lithium battery, that little lithium battery can keep track of your date and your time for you, and then every time you actually power the device on, the device will recharge that battery so that it appears as if the battery never dies. Okay? And then the very last one, which is kind of the cool one, getting into more physics and astronomy stuff, is the fuel cell. Basically what you need to know is the fuel cell is super, super, super expensive right now, and so we currently only use it in the space program. Now, technology keeps getting better and better, so who knows, but maybe eventually we will move over to fuel cells for cars to remove our dependency on fossil fuels, but currently it is way too expensive to try to do that, and most of those fuel cells are ridiculously heavy, and so your car would double its weight. And so then we run into some other issues as well. So currently we use fuel cells only for the space program. Section 2 is not that long. You just have to make sure you read about these 4 things and are able to identify the oxidation takes place where and with what chemicals, the reduction takes place where and with what chemicals, and then how they're used in real life. Okay, I split this unit up into 3 segments instead of the normal 2 to try to spread the work out for you a little bit. Okay, so make sure you read section 2 and you got a good grip on those 4 types of batteries.